are given that function p of x, okay, it is described by the following properties, that is k is greater than 0, where k is a base, okay, k is a base, k is greater than 0, but k is not equal to 1, and then the x-intercept is at x equal to 2 and y equal to 0, the horizontal asymptote is y equal to negative 9, right? And then 6.1.1 says, write down the range of P. Write down the range of P. Right? Now, I'm sure by now you all know that range is a set of all the Y values. So you need to identify a minimum and a maximum. Right? So in this question, if you want to determine the range, you have to know whether the function is increasing or it is decreasing. Right? Remember what I told you last time, that if you've got an exponential function, if a is positive, that is, okay, if I go back to the general equation, y equal to a times b to the power of x plus q. Please take note that when I introduce the general equation of an exponential function, I use b as the base, but you can get another letter like in this question here. The base is k, so it's not always a b. It can be any other letter, right? Then the constant a, which I told you it helps you to determine whether the function will curve upwards or it will curve downwards. Okay, it can also be any other letter. For our equation here, it's going to be a positive 1. Okay, so it's a positive 1, which means the function might be an increasing function. So it might go that way. Okay, it might go that way. But I need to be 100% sure based on the value of the base. The value of the base there, that k there. Now, my suggestion would be, it's better to calculate it so that you can be 100% sure. Because this property here, it doesn't tell us exactly whether the value of k is between 0 and 1 or it's greater than 1. So I'll just do a quick calculation here. Right, so if I substitute where there's p of x, I'll put, okay, let me substitute the x-intercept there. So y is 0 there. Then where there is k, I'll put k. Where there is x, I'll put 2. And then where there is q, I'll put minus 9. So if I simplify this, I'll get k being equal to 10 to minus 3. Which means there are two possible values of k. But remember, k is always, okay, if you remember last time, I told that the base is always between 0 and 1, or it can be greater than 1. So there are two possibilities. So among these two values of k here, you can't take the negative because the base can never be negative. So the base has to be positive. Since the base is going to be positive 3, and the value of the constant a is also positive, it means it's going to be an increasing function. Okay? It's going to be increasing 1 because the constant a is positive 1. The base k is 3. I have determined the base as a 3. Because the question itself is not straightforward about the value of k. But the good thing, it says that k is positive and k is not equal to 1. Okay? So I found that k is equal to 3. So it means it's going to be an increasing function. Therefore, the asymptote y equal to minus 9 is going to be below the x-axis. It's going to be an increasing function to go that way. I'll sketch it just now. So, because of that, the minimum value, okay, in terms of the range, is going to be just above minus 9. So when I write my range, I can just say y is greater than minus 9, but y is an element of real numbers. Okay? Remember, for you to be able to determine to write down the range, you need to know what is your minimum value. Okay, for the exponential function, you must look at the value of y along the horizontal asymptote. Also, you need to know whether is the function increasing or decreasing. If it's decreasing, you might have the asymptote above the curve, which means this value of y here is going to be the maximum. But if the asymptote is below the curve, then it's going to be like your minimum. But it has to be excluded. Are you following what I'm saying? I hope you are not rusty. Right? When it's increasing, it goes like that. When it's decreasing, it goes like that. In the decreasing case, you can have your asymptote above. Okay? In the increasing case, in most cases, the asymptote will be below that curve. Okay? In terms of the notation here, you can also write that answer as minus 9 is less than y is less than positive infinity. You can also write that range like that. It depends with your preference. All right, then 6.1.2, determine the equation for P. Right, now I want you to be aware that though I calculated K, the reason why I calculated K was for me to be able to determine whether the graph is increasing or decreasing by knowing the actual value of K. So for 6 point, so I'm done with that. 6.1.2, I now need to know the equation. To find the equation, I'm just going to redo what I did there to find K. So I'll substitute the x and y values at the intercept. Okay, 0 equal to k squared, right? Then you put y equal to minus 9. Then you solve here, which is what I've done already. So k is going to be plus or minus 3. Therefore, k is positive 3, because k has to be positive. Therefore, the equation for p, it will be p of x equal to p of x equal to 3 to the power of x minus 9. So that will be the equation for p of x. Okay. Then 6.1.3, sketch the graph of P, show clearly the intercept with the axis and the asymptote. Now here, the good thing is we are given the x-intercept, so I just need to determine the y-intercept if it exists. Okay, is there anybody else got any questions? Okay, let me move on to the next page. So I now need to sketch. Before I sketch, let me just find the y-intercept, if it exists. Remember, the y-intercept, you have to substitute x equal to 0. So I'll say p of x, which is p0 here. So that will be p0, will be equal to 3 to the power of 0 minus 9. Okay, so I'll get p0 equal to 1 minus 9, and that will give me minus 8. So the graph is got the y-intercept at x equals 0 and y equal to minus 8. So let me sketch now. Minus 8 is somewhere right at the bottom. So let's say that is positive 2, negative 2, negative 4, negative 6, negative 8. So when you are sketching the exponential function, first thing you must draw your horizontal asymptote. Okay, that's the first thing. You must draw your horizontal asymptote. So my horizontal asymptote is going to pass through somewhere there. Please use a ruler. I don't have a ruler. Okay, that's where my horizontal asymptote is. And I'm going to write the equation of that horizontal asymptote, y equal to -9. So I have an x-intercept here, and I have a y-intercept there. So when I sketch it, it's going to be an increasing function. The asymptote is below is going to be below the curve. So when I sketch it, it goes something like this. This is not perfect, but it looks something like that. Right. So it looks something like that. Then you can label it. P of x is equal to 3 to the power of x minus 9. Okay. So this is how it will look like. Okay. Any question? Okay, if you don't have a question, let me move on to the next one. Okay, let's just add the domain. We already wrote the range. The domain will be x is an element of real number. That's your domain. In actual fact, for any exponential function, your domain will be x is an element of real numbers. So I'm starting from minus infinity all the way up to positive infinity. Okay, I'm just going to give you a question based on this graph. Okay, this is the question. I'll put question 6.4 on the next page. This is the next question. Determine the equation of, well, let me call it h of x if h of x is equal to minus p of x plus 3. Can you find that equation? So what's the answer? What's the answer? Huh? What's the answer? Minus 3x plus 12. Minus 3x plus 12. Okay. So it's very simple. Generally, from my experience, some learners, they think if you see that it's very difficult, you just go back to the basics of function notation. That's the easiest way. So where there is p of x there, you substitute this. Okay? So where there is p of x, I'll put 3 to the power of x minus 9. It's so simple. Right? So this becomes minus 3 to the power of x minus 9 plus 3. Remember, what does this plus 3 stand for? It represents the vertical shift by 3 units upwards. And what does this minus mean? Because you have to know that. What does that minus stand for? There are two types of reflection. Be more specific. Which reflection? It's a reflection about the x-axis. Okay? So, when you reflect this function about the x-axis, it becomes a decreasing function. Okay? The asymptote moves to the top. It becomes y equal to 9, which is a positive. And the curve itself will be drawn below the asymptote. Okay? Right, so that, then when you simplify, you get minus 3 to the power of x plus 9 plus 3. And this gives you minus 3 to the power of x plus 12. So that's your new equation. There is no need for your heartbeat to increase because you have seen this in a test or in an examination. There's no need. Okay? Because it's not difficult at all. Right? So these are some of the basics that you are expected to know in grade 10 and also as you go higher up. Right, the next question. This was a combination of a straight line and a hyperbolic graph. Okay, so you are given the equation of the hyperbolic function. It's f of x plus k over x plus w, and the straight line is g of x equal to minus x minus 1. Right? Then the graph of g is an axis of symmetry of f. So this graph here is an axis of symmetry. The graphs of f and g intersect at point q and also at p there. So the first question says, write down the value of w. What will be the value of that w there? By inspection. Huh? Yes. So you can see this value here. The equation is it's f of x equal to k over x plus w. And the straight line is g of x equal to minus x minus 1. So the question is saying, what is the value of that? By inspection, what would be the value for that letter? All right, thank you. All right, can I have your attention? The lines of symmetry, remember there are two of them. I think I gave you the equation. You have to do yourself a favor and make sure you know this because it's a very important concept. Right, your lines of symmetry are the following. The equations. The one with the positive gradient is y equal to x plus. Okay, because this is grade 10, it's x plus q. Okay, based on the general equations that I taught you. Okay, then the one with the negative gradient is y equal to minus x plus q. Are you following that? Now, the lines of symmetry and the axis of symmetry, the lines of symmetry and the asymptotes, they intersect at a common point. Did I tell you that? I think I did. The lines of symmetry and the asymptotes, they intersect at a common point. Okay? So here, I'm sure you can see that this Q here, that Q there, it's also the value of y along the horizontal asymptote. Do you see that? So I can just identify my value of q from the equation of the line of symmetry. Okay, so our equation of line of symmetry here, it's g of x equal to minus x minus 1. What that means is this minus 1 here is equal to q based on how I taught you. But based on this question here, that minus 1 is going to be equal to w. Because w is equal to p for this question. So it's equal to q for this question. Right? I think some of you are forgetting y equal to a over x plus q. This is how I taught you. But for this question, the a is equal to k, the w is equal to q. Are you following that? Therefore, that w is going to be equal to 1. So it's negative 1. No sign changes. Look here. Okay, look here. There is a positive q in the general equation. And here there is a minus 1. So what will be q equal to? Minus 1. There is a positive q, sorry, a positive w there. And here there is a minus 1. So w is going to be equal to negative 1. Also, if you look on the graph, can I have your attention? If you look on the graph, the line of symmetry has got a y-intercept which is below the x-axis. Okay? There's a y-intercept which is below the x-axis. Because of that, it means the value of w is going to be a negative. Okay? It means this line, what is known this, y equal to minus x was moved by 1 unit downwards. And this is a line of symmetry with a negative gradient. For the basic graph, the basic graph where w is 0, its line of symmetry is this. So if you move the line of symmetry down, the hyperbolic graph also moves what? Also moves down. And the asymptotes also move. Okay? So because we have a y-intercept, you see this minus 1 here, it is the y-intercept here. And if I were to draw the horizontal asymptote, it would be like, it will pass through the point where the asymptotes and the axis of symmetry intersect, where they intersect. I think I drew a graph. If you go back when I did an example on the hyperbolic function. I remember drawing the lines of symmetry or axes of symmetry together with the asymptotes, and they were intersecting at a common point. Do you have that graph? Now, that's a very important concept that you need to know from grade 10. Okay, so your axis of symmetry, your asymptote, they intersect at a common point. Okay, even if I were to draw the line of symmetry with a positive gradient, it will go like that, it will pass through this point. Okay, right then, 6.22. So you are given a point on the graph where x is minus 2y is 7. Calculate the value of k. Now this is easy now because we now know what the value of w is. So that's 6.22. So f of x is equal to k over x minus 1. Okay? Now, by inspection, before you do any calculation, you should have an idea whether k is supposed to be positive or negative. I want someone at the back to tell us whether k will be negative or positive. Does it tell us? Is k going to be negative or positive before we calculate? So you can guess if you're not sure. Based on the two curves in the pattern which they are, is k going to be positive or negative? Huh? Okay, k is going to be negative because because, can you pay attention? K is going to be negative because the two curves are drawn in the second quadrant and the fourth quadrant. So, when you are answering questions like this, you must use common sense. Don't just do a calculation without asking yourself questions. So when I calculate this value of K, I must not get a positive answer. It has to be negative because the graph is telling me so. Okay? So where there is Y, I'll put 7. Where there is K, I'll put K. Where there is X, I'll put minus 2. Then I'll take the minus 1 to the left, I'll get minus 8 equal to K over negative 2. So K is going to be negative 16. Okay, K is going to be negative 16. K has to be negative because the two curves are in the second and the fourth quadrant. Are you following that? Right. Can I move on? Then 6.23 says calculate the x coordinates of P and Q. X coordinates of P and Q. Now to calculate those coordinates, obviously you have to be aware that this is the point of intersection, that's the point of intersection. Okay, so if two graphs intersect means they are equal at that point. So we start by saying f of x is equal to g of x. We now know that f of x is minus 16 over x minus 1. G of x is minus x minus 1. Okay? Then your knowledge of equations from term 1 is required for you to carry on from that point. Right? So I'll find the LCD, which is x. So this becomes minus 16 minus x equal to minus x squared minus x. Okay? Right. I'm just using my knowledge of equation from term 1. This becomes minus 16 plus x squared equal to 0. Okay. You can also start by eliminating these two constants. Because I'm not teaching equations. That's stage past. Right? If you take either of those two to the other side, they will cancel out. Okay? Then here I'll end up having a difference of 2 squares. Then I can solve this. So x will be 4 or x will be minus 4. Okay? Here they only said determine the x coordinates. Then I'll say, well, xp, the value of x there is going to be negative 4. Or xq is going to be positive 4. And then you are done. Now in this case, we are only finding the x coordinates. Okay, x coordinates. No y coordinate is required. So you just have to stop there. Alright? Now, I'm not going to do question 6.2.4 to be part of your homework. You'll go and figure that out. Right? In the meantime, now you need to write it down.